Assalamu alaikum, Zoya. How are you?
Walaikum assalam. I'm fine. How are you?
I'm good. All right. Mhm. Let's begin. What were we doing the last time around, Zoya? I think we did simultaneous equations. Hmm. Today we're just going to, speed run through the graphs and stuff. So, Assalamu alaikum, Basit. How are you? All right, guys. Hopefully you guys can hear me clearly. Okay. So today we're beginning equations and their graph. And we saw this in our last class as well, and a few classes ago, that equation, regardless of whether they are linear or quadratic, non-linear, whatever they may be, they are going to form some particular graphs. And we saw that linear equations always form linear graphs, or you can say straight line graphs, whereas your non-linear equations, they gave you curves on the graph. See today how those curves come in. All right. First up, we are going to see linear equations. So we already know what are the characteristics of a linear equation. It is defined as what you may call a linear equation is your y is equal to mx plus c. That is your simply y is equal to mx plus c, and what is that? And it's always going to be a straight line. The linear equation is always going to be a straight line. But what more importantly, we know that the general form of the equation is going to be y is equal to mx plus c. Now we need to see what do this y, x, and this, like for example, m and c stand for. So y and x, they're like pretty simple to actually understand. Your y and x are simply your coordinates. So y and x are your coordinates, the ones that you're simply going to plot on the graph, and they're variable. So they are your coordinates. At the same time, what's going to happen is that what is m? M is simply defined as your gradient. Can anyone tell me what is the gradient? Guys, yes, Koji, what do you understand from gradient?
So can you repeat?
Hello, can you guys hear me? Can you guys hear me? Hello, Kushi, can you hear me?
So your voice is breaking in between.
Just give me a moment, guys. Yes, guys, can you hear me?
Yes, sir.
Kushi, can you hear me clearly now?
Yes, sir.
All right. Kushi, yes. What do I mean by the gradient? What do you think is the meaning of the
So
word?
the
Mm-hmm.
gradient, it's like we're trying to measure how steep our slope is by how much our slope is increasing or decreasing.
Perfect. That is absolutely what it is. It is a measure of how slanted your line is. and C is simply your y-intercept. All right, that is simply going to be your y-intercept. Just give me a moment, guys. Just all right. So what's going to happen now simply is that C is your y-intercept, M is your gradient, and your y and x are your simply coordinates. And we already know one aspect of this, that for a linear equation, it is always going to be a straight line. Always going to be a straight line graph. So now what's going to happen is that simply we are going to move forward with this and see what your y-intercepts and C and gradient and coordinates actually mean. So your y-intercept or your what you may call C is very simply the point at which, just like it says in the name, it's the point at which the graph hits the y-axis. There, guys, can you guys hear me clearly? Internet is causing a bit of issues today, so I hope you can hear me.
Yes, sir.
All right. So the y-intercept is as simple as it sounds, that it's the point on the y-axis where the graph cuts the y-axis. Where the graph intersects it. All right. And at this point, you can also say that this is the point on the graph where x is equal to 0. So therefore, if x is equal to 0 and y is equal to c at that point, we usually determine it by writing it with the variable c. That means that my coordinate is actually 0, c. Obviously, c is a variable. It's going to be replaced by some sort of number. But yeah, now what's going to happen next is that you're simply going to have what you may call the, now we're going to look into gradient. Now, this is something that is highly important because when we move on to y-intercept is, going to remain as it is throughout. Gradient, however, is going to, change as we change the type of equation that we're currently doing. So it's the measure of the degree of steepness of the degree of steepness. What do I mean by that? That how steep a line is. Technically, we don't say it like this, but think of it as in how much bent it is in terms of, angles. How much, which angle is it positioned at? But we don't usually say that it's positioned at an angle because in order to specify that it is an angle, I want to have, an angle is only formed because an angle is only formed when there's an intersection of lines. And over here, there's no intersection. So it's a measure of the degree of steepness. Okay. How do you calculate it? How do you calculate gradient, guys? Who can tell me? Yes, Abdul Basit.
y2 minus y1 over x2 minus x1.
Yes, what Basit said. Technically, what Basit meant by was that your gradient is equal to change in y over change in x. Why does it mean this? Because your gradient is also referred to as your slope, and it is also referred to as your rise over run. And what do we mean by this? We mean by this that it is simply going to be how much vertical displacement you've had, vertical displacement, how much you've moved vertically, and how much you've moved horizontally. Rise over run. This is running. Regardless of whether it's over there or there, that's another issue. So technically, how do we calculate the gradient? We say that this is a change in the y-axis coordinates over the change in the x-axis coordinates. So what is it going to have? This is going to be equal to y2 minus y1 over x2 minus x1. Now, one more thing that I would like to add, do not think that the greater number or the larger number has to be y2 or something like that. It does not matter. The arrangement does not matter. What only matters is whether you're using the right correspondence. And what do I mean by correspondence? Is that if you're using y2 first, then x2 should be first. It's not as if you use y2 above and x1 below. That will be wrong. All right. It's a measure of the degree of steepness. Okay. Let's see a few gradient, gradient of some lines. So for example, if it's a line like this, and let's just call it L1, and there's a line like this. Which line do you guys think has the more gradient? Hmm? Yes, guys. Come on, guys, quick. Tell me which line do you guys think has a steeper gradient or has more gradient? Yes, Sad. Yes, Sad.
Line 1.
Okay, so I can simply say that line 1 you're saying that has a greater gradient. Hmm. Okay,
Yes.
Sad is saying line 1. What about you, Kushi?
So it will be line 2 because the run is less.
Yes, well done, Kushi. Sad, why is line 1 going to have a lesser gradient? Because the gradient is the measure of the degree of steepness of a line. So the more steep a line is, the more slanted a line is. It is going to have the same thing. All right. So, for example, the usual example that I give my students is that, consider this and consider this. Now, more or less, they both are at the same peak right now. For example, let's just say that, there's a house that you go to over here. And this is the same house over here. And let's just say that Saad is over here. This is Saad. And Saad, now you have to go to this point. And if you're right about over here, if you're over here too, and you have to go directly now. Saad, what do you think is going to be a much more of a slope, which is more steep, where the slanted mountain is? Clear, Saad? So that is why, guys,
Yes.
remember that this is a lesser value. Why? Because you're running more. There is not a lot of vertical displacement. There is a lot of horizontal displacement. We can actually see that. For example, you move a lot to the, what you may call, uh, to the left or to the right, sorry. and you're not moving a lot to the uh, you're not moving a lot up. Whereas same cannot be the said over here. Over here, what is happening? You're moving like literally, you're not even moving a lot of spaces over here, and you're moving loads over here, like loads and loads, like this. Clear? You guys can clearly see the difference. So, and gradient is what? Change in y over change in x over. So if your denominator is bigger, which is in case of when you know it's less steep, and if your numerator is bigger, over here your numerator is big and your denominator is small, then which number would be greater? Obviously, this would be a greater gradient, this would be a lesser gradient. Why? Because change in y is less. So technically, if you were trying to judge what is your gradient dependent upon, your gradient is actually dependent on the value of y. Not entirely on the value of y, but for example, you can say that it's going to be what you may call um, value of y with respect to value of x. Clear? So Kushi was right in that case that what you may call we have had over here that the gradient of line 1 m of L1 is going to be less than the gradient of line 2. That is how it's going to be. Clear, guys? So the gradient of line 1 is going to be greater than the gradient of line 2. All right? Just give me a moment, guys. All right, note this down. I'll be back in 2 minutes. All right, guys. Apologies about that. Let's begin again. So we saw over here that your gradient of one particular line, which is L2, is greater than your gradient of line L1. And we already know why. Okay. Mm, what is this? What is going to be the gradient of this line? Yes. Yes, Zoya.
It's going to be negative.
We will done, Zoya. Yes. Now the gradient of this particular line is going to be a negative number. Regardless, we don't actually care about the magnitude, but gradient in this direction is going to be negative. All right. What about this one? Again, draw two pairs of lines. And this is going to be like this. One line is going to be like this, and the other line is going to be like this. What do you think is the gradient going to be for both of these lines? Yes, yes. Just give me a moment. Yes, guys. Who raised their hand first? Zoya? Yes. Was it Zoya first or Sam?
No,
I don't
sir,
know.
it
I think
wasn't
this.
me.
What? Sorry, Zoya?
It wasn't me.
All right. Thank you for that, Zoya. Yes, Sad. Can you tell us?
It will be 0.
Or for which one?
Both of them.
Okay, both of them. Saad is saying it's going to be 0 for both of them. Who agrees with Saad? Raise your hand. Whoever agrees with Saad, tell me. Yes, guys? Someone's agreeing with Saad. Zoya agrees with Saad. All right, Zoya. What do you agree with Saad for? You think it's going to be 0 for both?
Yes.
Okay, Zoya says it's going to be 0 for both sides. All right. Sleeping? Hello? Is everyone else sleeping? Yes, Khushi, you think it's 0 too for both?
No, sir. I think that the vertical line will be undefined.
Well done, Khushi. It's going to be infinite. It is going to be maximum. It is the maximum gradient you can achieve. Why, Zoya and Saad? Your vertical displacement. Okay. Before we move, and this is 0. You guys are right about this. Okay, now I'll explain this to you. For this gradient, you can notice that there is change in y and change in x. But the problem is there is no change in x. There is no vertical displacement. The line is going perfectly upwards. What is there supposed to be change in? So what's going to happen? You're going to have some sort of change in y over 0. And anything divided by 0 is going to be bingo. And if the gradient is equal to 0 over here, why is the gradient equal to 0 over here? Now let's see. Gradient is equal to what? This is what the gradient is equal to. And the only issue is that there is no change in y now. There is only horizontal displacement. So it is going to be 0 over delta x. And if 0 is divided by anything, the answer is 0. Is this clear, guys? Anyone who does not understand this, let me know. Yes, Khushi.
So I have a question. So if we ever have to write the value of y Do we write undefined or do we show the infinity symbol?
Both can work, Kush.
Okay.
It means the same thing. What is undefined? It is the answer is either too big or too large. Oh, it's the same thing. The answer is too big or too small that you cannot write it. My infinity sign does not look good, right? All right. What is undefined? That the answer is such an answer that you cannot define it. So that's infinite. Infinite number of, answers that you could have. All right. And one big property that we need to know regarding gradients is what, guys? What is property of gradients? Does anyone know? They are constant for straight lines. A gradient is constant for straight lines. Also, it's, for collinear lines as well. The gradient is constant. Is this clear, guys? Anyone who does not get this, let me know. All right. So simply, yes, sir.
Sir, what are collinear lines?
Collinear points.
Oh, okay.
Clear, sir?
Yes, sir.
All right. Points that exist on the same line are considered collinear. What do I mean by collinear? That they exist on the very same line. So obviously, if the entire line has the same gradient, if the gradient is constant for straight line, if the entire line, what does that mean? That if you've calculated the gradient at one particular point, it is going to remain as such throughout the entirety of that line. So what you're simply going to have is that at any given point on this straight line, the gradient is the same. Clear? All right. Now let's move on to quadratic equations. All right. So for example, now this is where it gets a bit interesting. This is going to require some strength from your end as well as to understand this better. We saw linear equations. Now we're going to go into quadratic equations. The general form of a quadratic equation is y is equal to ax squared plus bx plus c. Again, c is your y-intercept. X and y are your coordinates. X and y are your coordinates. And A, B, and C are just simple constants. They have absolutely no A and B have absolutely that they've got absolutely no importance whatsoever. Apart from the fact that A has the utmost significance of determining which shape your graph is going to take, which shape your curve is going to take. How is that going to be the case? We'll see. So, for example, oh, come on. Now, the value of A is extremely important. How so? That you're simply going to have constants. And one thing that we're going to be determining from this constant is A is exceptionally important. Now, why is A exceptionally important to me? Is because A's value, okay, A can coexist as what? A can either be negative or A can be either be positive. Now, if A is a positive number, regardless of the fact that it's, maybe it could be 1, the coefficient of the x squared term is going to tell you where your graph is going to twist and turn. So, if A is negative, we get a frown. The graph, the quadratic curve is going to be facing upside down. Not upside down, it's like kind of like an A-shaped graph. It opens downwards. But if A is a positive number, all smiles, not like that. Is this clear, guys? Any issues with this? Anyone who does not get this at all? All right. How do you find the y-intercept? You put x is equal to 0. That is what we already know. Oh, sorry. How do you find the y-intercept? Yes, you put x is equal to 0, as we did in the previous part. But this time around, we're going to do things a bit differently because you're going to have x-intercepts as well. How you're going to have x-intercepts? Maybe the graph cuts the x-axis too. How are you going to have the x-intercepts? Simply, these are also known as solutions to the graph. Solutions to the equation. Your x and n. I'm telling you the keywords that the examiner might use when asking for the x-intercepts of the graph. He could ask you for solutions to the equation. He could ask you real roots. And he could simply ask you to solve this. And what you're supposed to do over here is simply put by is equal to 0. All right. So that is how your quadratic equation graphs are going to come into play. Like, for example, if it's a graph like this. All right. If it's a graph like this, what's going to happen is simply you're either going to have some, what you may call, whether it's a graph like this or it's a graph which is like this. And just shrink this one a bit. Whether it's like this or like that, we don't matter because it can have x-intercepts. These guys are going to be your x-intercept. All right. Is this clear? Is there anyone who does not get this? All right. Now, guys, I told you guys above as well that, for example, yep, no, Saad. Yes, Saad.
Sir, is B important?
Not really. B is absolutely useless. Obviously, it is important if you're trying to solve it, but it, but it does not have any significance as C and A does or do. All right. So, for example, C is your y-intercept, A is going to determine B. Yes, it does not have that specific importance, but it is very important because if you're trying to use middle term breaking to solve this equation in order to get solutions of the equation or the x-intercepts, then obviously you're supposed to use B. But it does not have any specific importance if that's what you were mentioning. All right. Now, yep. Yes, sir.
So for the second graph that you've drawn, what will be the value for y?
0. Value for y what? Y intercept
Y-intercept,
is
yeah.
0.
But it's not cutting the y-axis.
Yeah, 0. There is no x and there is no value of c. C is equal to 0.
Okay.
Okay. Wait, I'll explain this to you. Zoya, is there any y-intercept for this graph? No. The graph ends over here. We are only concerned about this portion of the graph. So then the y-intercept will also be 0. But usually that doesn't happen because, and also the graph of y is equal to x. That is a straight line graph which passes through the origin. So that also has c is equal to 0. Clear? Also, Zoya, there could be one more scenario in which your graph is, if it's a quadratic graph and it only has one x-intercept, like it just touches the graph. That can be the case too. So the possibilities are endless. Now, what I'm concerned with is the fact that how do I find the gradient of a quadratic curve? This is the $1,000,000 question that I want to be asking you guys. Yes, Basit.
We draw a tangent.
You draw a tangent. Why do we draw a tangent, Basit?
So that we can calculate wide rise over run, change in y and change in y.
But why?
Because we cannot calculate gradient of a curve, we need a straight line.
Sorry, could you repeat that last thing? What did you say?
Sir, we cannot calculate the gradient of a curve, we need a straight line. We need to calculate the gradient.
You cannot calculate the gradient of a permeable straight line? What? What is it?
Sir, we cannot calculate the gradient of a curve. We need a straight line to calculate.
Okay, right, Basit. Basit, why are you so angry? Why are you shouting? All right, I can hear you. All right. So what Basit is saying that the gradient of a curve cannot be calculated. Basit is right and Basit is wrong at the same time. Basit is absolutely right when he is saying that you need to draw tangent. He is absolutely right that we cannot calculate the gradient of a curve. We need a straight line. But Basit is wrong when he says that the gradient of the line cannot be calculated. It can be calculated. The only issue is that the gradient is changing. Why? The gradient was constant for straight lines. Gradient is obviously not going to be constant for curves. So the gradient is non-uniform, which means not constant. The gradient is non-uniform for curves. So if the gradient is non-uniform for curves, that means it is changing at every and common sense, guys. It is changing. Look at it over from here. It is much more steep, gets less steep, almost changes completely direction, and then So it is much more steep over here, less steep over here, very less steep, almost zero over here, and then so the gradient is always changing. And in order to solve the gradient, you've got two methods. Can anyone tell me one method? Basit has already told. Can anyone tell me another method? Yes, sir.
We can use differentiation to find the gradient.
Yes, sir. Well done. Yes. So two methods are there to use for finding out of the gradient. We're going to do them one by one. The first one is going to be by tangent. I absolutely hate this method because of the fact that I can never draw a tangent. My drawing is pathetic. So let's see. Okay. Consider a graph and there's a curve on it. Consider a graph like this. If I want to calculate the gradient at, let's say, let me zoom in at this point, right? That's too big. And that's too small. It's all right. If I want to calculate the gradient at this point, and obviously I'll have to calculate the gradient at this point too. Okay. If they tell you to find the gradient at this point, now that is a bit of a hassle. Why? Because the gradient is constantly changing throughout. What I'm going to do is that I'm simply going to draw a straight line. I'm being ultra professional today. You're going to draw a straight line, preferably not dotted. You're going to draw a straight line, and you're going to make sure that that line touches the graph at just that point. I cannot zoom in more. I hope you guys can see. You can clearly see that that line touches the graph at that point. Such is that line touching the graph at that point is that we have ourselves mhm, that that point is now collinear. Is this clear? The point at which we were asked to find out our gradient, that point is now known is a collinear point. Why? Because that point is also touching our tangent and it is also touching the, obviously it is on the curve. So that point lies on the curve itself. Clear, guys? What is that going to do? I have already told you that collinear points. Why is it so? Okay, I am too much zoomed in. It's not an issue. This is your tangent. Now, what is going to happen? Simply because straight lines have constant gradient and we have drawn the tangent such that it touches that point alone and no other point, that means that the point and the tangent are, all the points on the tangent are collinear. And what do we mean by collinear points? That they exist on the same line, therefore they are going to have the same gradient. And if they are going to have the same gradient, that means I can simply calculate the gradient. Wait, this is x. So what can happen? I can simply calculate the gradient at what you may call is equal to at that particular point that you wanted to calculate the gradient for, and that is equal to the gradient of the tangent. All right. Is this clear, guys? Because these two lie on the same point. Anyone who does not get this? So you just need to find the gradient of the tangent, and that is going to help you find the gradient at one particular point. Why? Because the gradient for is non-uniform for curves. It's going to change throughout. Okay. This method is really, really easy to do because like you just need to calculate the gradient by some sort of change in y over some sort of change in x. But why this method looks very easy, right? Just draw it and stuff. Why do I hate this method? Yes, that's the question. That's the question to every single one of you. Why do I hate this method? And by the way, Assalamu alaikum, Fahad. I didn't see you. How are you? All right, Fahad, you answer this. Why do I hate this method? You've known me for a long time now. Yes. Fahad, can you hear me? Hello, guys, can you hear me? Honey, Khushi, guys, can you hear me?
Yes, sir.
Yes. What's wrong with the Fahad? I don't know what's wrong with Fahad. All right, honey, yes, let me ask you. You've stayed quiet throughout this class. Honey, why do you think, the tangent seems to be a reasonable method to solve for the gradient? Why do I hate it? Yes, honey. What could possibly
I
make
don't know.
think? What could possibly make me hate using the tangent, apart from my obvious drawing skills?
I guess. Uh, I don't know. Wait, let me think. The lines are hard to draw or hard to differentiate or too
Hmm.
many lines to draw.
Okay, yes, actually. Well done, honey. The
Oh,
gradient is ever changing. The gradient is ever changing, right? At this point, let us zoom in. At this point, the gradient is something else. At this point, it is going to be something else. Similarly, at this point, there are millions of points on the curve. Are you going to draw millions of tangents? No, I'm not dumb. Why would I waste so much time trying to draw tangents? That's like so weird. And also, it's never going to be an accurate representation. Why? Because it is so hard to make sure that only that point touches the line and no other point does. And also, one more thing, do not cut the tangent through the curve. The tangent has to be always on the outside of the curve. All right. Therefore, yes, Honey was absolutely right. I hate the uselessness of the method. The method is absolutely useless. All right. So now what's going to happen is let's look into what was the other method there by differentiation. Yes. But this method is very easy and not that easy though, to be honest. But it employs one method. Like there is one procedure of doing this method, and that's very easy. You can do that for every question. But thankfully so, I have less time today, so we're going to do this tomorrow. All right. Is there anyone who did not get anything from above? Questions, people? Yes. Is there anyone?
Sir, I have a question.
Yes, I sorry,
Um,
didn't put your hand. Yes.
yeah, it's okay. So you said that the tangent should not cut through the graph. Does it mean that the tangent should touch the point, or does it have to be outside the point of the graph?
It has to touch the point. It always has to touch the point. All right. Wait, let us do a question. We have time. I don't have time for gradient, but I have time for questions. Wait, let me see. This is IGCSE. Hmm. Also, Fahad, we cannot hear you if you're saying something. Fahad cannot hear us. Yes, this is a question. Ignore the solution, please. No, you guys cannot see. Mhm. So there's this question. Now what you're going to have is, let's look into this question. The curve y is equal to x cubed plus 2x squared minus 4x is shown on the grid. By drawing a suitable tangent, find an estimate of the gradient of the curve when x is equal to 1. When x is equal to 1, this is it. That's the point. Okay. I need to draw a tangent and I need to make this such. I need to remove this. It's too big. Now, hopefully, I just need to touch the point. Yeah, it looks about right. Now what's going to happen? Clear the way? It is touching the point, but it is touching nothing else. Clear, guys? Is there anyone who still doesn't get it? Yes, people. Is there anyone who still does not know how to draw the tangent? Now you can calculate and Zoya, look over here. Find an estimate of the gradient to answer this question. Because you're going to be unsure of yourself as well. Obviously, it's not an accurate method. You're always going to be unsure because it is very difficult to make the curve only touch that point. I can use the tools over here and zoom in and zoom out, but obviously you guys cannot. So it's supposed to be an estimate of the gradient of the curve. And how do you calculate the gradient? It's just simply going to be take any 2 points on the line. And also, just a bit of advice. Try to take 2 points on the line which are whole number points. Like they're going to be obviously there's millions and millions of points over here, but this point is almost 2, 2. So this is a good point to take because if you take like this point, this is like 1.75 and this is like 0.6 or something. That is just you're making it a bit more harder for yourself to solve because there are decimals. All right. Okay. So hopefully this is clear. Is there anyone who does not get this? Any questions at all, guys? Also, apologies. I forgot to post the notes again. I will do it by today. Hopefully, if I remember. If I don't remember, but I will. All right. Yeah, Zoya.
Sir, when are we going to get our checked quizzes?
You did not receive them?
No.
Also,
Let me double check as well.
let me see too. Supposed to be on Google Classroom. I was told that you guys that the quizzes have been checked. Let me see. Where are you, Soya? No, you guys have not been. When was this quiz, guys? I don't even remember now. The January 10th one? Was it marked? Was it marked or was it not marked? All of them. Okay. All right, guys. I did not realize that the quizzes were not marked. Probably for your section, they have not been marked. Apologies. I will try to do so by the end of this week. By the end of this week, you will probably get all of them marked. All right. And is there any question anyone else has for me? Yes. It feels as if only me, Zoya, Saad, and Kushi are in class. And sometimes Basit, whenever he wakes up. All right. Nonetheless, thank you. And Hani also. Hanim and Fahad have completely skipped the class. All right, no worries. Enjoy it while it lasts, guys. I'll see you guys tomorrow. Until then, keep smiling as always. Allah Hafiz. Bye bye. Have a nice day.
Bye, sir.
Love.
Bye bye. Allah Hafiz. Honey,
Oh, yes, teacher. Allah Hafiz.
you want to stay here for another hour? I can manage that too. No worries.
No, teacher. Allah Hafiz.
Allah Hafiz, honey. Allah Hafiz. I'm just kidding.